Hi everyone, I'm Emanuele Iannone, a first year PhD student at University of Salerno. Together with Dario Dinucci, Antonino Sabetta, and Andrea De Lucia, I'm going to show our work named Toward Automated Exploit Generation for Non-Vulnerabilities in Open Source Libraries, presented at the ERA track. Software use is a common practice in modern software development. So, we can say that almost no software product can live without using any open source library or framework. But sadly, these regularly suffer from defects of any kind, especially software vulnerabilities, so we aren't able to fully trust them. OWASP Foundation since 2013 has been warning developers about the security risks caused by an improper use of open source components in web applications. So our problem is indeed relevant. Our main weapon against this risk are static analysis tools, which unfortunately have been shown to have low precision in detecting vulnerabilities in third-party components. So a combination of both static and dynamic approaches seems to be the winning factor. This combination, however, requires a quite good quantity of test cases to start the execution with, which are often unavailable or insufficient. We present Siege, a novel technique for the automatic generation of exploits of vulnerable open source components, included through libraries or frameworks as dependencies in a client application. Suppose we have our client application like this that includes a library with a vulnerable class E, which is the root cause behind a certain non-vulnerability. We want to assess if this component is actually exploitable, meaning that are we able to generate a test case that executes it? If we tell Siege the location in the code of the target vulnerable component, it generates a set of JUnit test cases evolved with a genetic algorithm. These tests start their execution on the client's classes, and the closer they approach to the target vulnerable components, the higher their fitness scores. At the end of the evolution, we would have a JUnit test case, which is able to reach the target component. This has an interesting security implication. If our algorithm is able to generate exploits with a low search budget, then the likelihood of creating real exploits by a real attacker is higher. Our preliminary validation on 11 vulnerabilities showed us that the exploitation performance is indeed influenced by the specific vulnerability and how it is coded by the client classes. We aim to integrate our approach to known vulnerability detection tools, as well as improve and extend our validation. This concludes my presentation. Thank you for the attention.
Hello, everyone. Just like the other talks, please leave your questions in the paid chat if you have any. Meanwhile, we have a question from the audience. So it's from Fabiano. You said that your evaluation was done preliminary on 11 known vulnerabilities. How do you plan to improve and extend it?
Okay, well, we plan to consider real-world projects, since for the sake of this preliminary evaluation, we done it on artificially crafted project, and so extending the number of vulnerabilities, not only 11, but going on a large scale, and trying to tweak different genetic algorithm settings in order to improve the performance of Siege, the approach.
Okay, awesome. Thank you. So I think we'll be out of time by the time we ask the next question. So let's move on to discussion area.
Okay.
And we can answer.